It's springtime in Wisconsin, and the holiday weekend offered some of us the first opportunity to get our pasty skin in the sun, as you can see from my face. I apologize. It's also the first time that those dusty jorts got pulled out of the bottom drawer so people could show off their scars of winter surgeries healing just in time for summer. So was the case for my father-in-law, who has been hobbled by a failed stem cell treatment and a subsequent knee surgery. Well, new work out of Duke University could have eased his suffering and sped up his recovery. The team is 3D printing knee implants with a hydrogel that matches the strength and elasticity of human cartilage. According to the researchers, this could mean creating custom replacement parts using info taken from your CT scan. Specifically, they printed menisci, the little piece between your shin and thigh bone that stops the bones from rubbing together. Until now, researchers have struggled to create recipes for synthetic hydrogels that are equal in strength to human cartilage and also 3D printable. Duke's recipe is 1 part stiff hydrogel, 1 part soft and stretchy hydrogel, and then they added a special ingredient, a nanoparticle clay. This allows the hydrogel to flow like water out of the printer head and then immediately harden into its printed shape. They call it a double network hydrogel. Really had a vision for that one. And we'll call it double network hydrogel. I have created a new product and it shall be called double network hydrogel with clay. The entire process from scan to the finished meniscus only took them a day. And, perhaps more importantly, they did it on a cheap $300 3D printer. From this day forth, this hydrogel shall be called Double Network Hydrogel! Ha! Did you see him? He was agave. Researchers at the University of California, Riverside's Bourne College of Engineering are smashing old glass bottles to create nanosilicon anodes for lithium-ion batteries. According to the researchers, the batteries will not only extend the range in electric vehicles and plug-in hybrids, but it will give our personal electronics a little bit more power on fewer charges. The team used a 3-step process to create the anodes. First, they crushed the glass bottles into a fine white powder, likely the most fun part of the entire process. Then, they used a magnesiothermic reduction to transform the silicon dioxide into nanostructured silicon. Finally, they coated the silicon nanoparticles with carbon to improve stability and energy storage. According to the team, 1 glass bottle provides enough nanosilicon for hundreds of coin cell batteries, which unfortunately still leaves billions of bottles headed for the landfill. But I mean, who knows? Maybe one day they could use it to turn it into battery holders. Find a better way to hold their batteries. 2 for the money! 2 bottles! Still billions of bottles in landfills though. And that is a bummer. Did you see him? He was agave. Last year, Ford partnered with Jose Cuervo to make car parts from agave. The plan was to make a sustainable bioplastic material from the agave fiber byproduct after the plant's heart was harvested to make tequila. Quite possibly the only way an alcohol producer could partner with a car manufacturer. And it's only one of the company's many projects to find a use for sustainable and recycled materials. I mean, this week, researchers at Ford's Nanjing Research and Engineering Center in China said that they have spent the last few years working with bamboo to try and find a way to use it for car interiors and make stronger parts by combining them with plastic. The team actually found that bamboo performs much better than synthetic and natural fibers, particularly when it comes to tensile and impact strength. It can also withstand more than 212 degrees Fahrenheit, which can withstand just about anything except, like the car catching fire. So, up until that point, great material. Post-fire, no good, but I mean, everything's pretty much a loss after that. The bamboo and tequila chaff are actually just a couple of the company's efforts to make its vehicles more sustainable. Some of them might already be in one of your vehicles. The company uses tropical plants to make Ford Escape doors, Reprieve fabric in the F-150, that's made out of recycled plastic bottles, and cotton from denim and t-shirts as interior padding and sound insulation, as well as old tires for seals and gaskets in most vehicles. Rice hulls are used in the F-150 electrical harnesses, and cellulose tree fibers can be found in the Lincoln MKX armrests, where it's used to replace glass-filled plastic. It actually weighs 10% less, is produced 30% faster, and reduces carbon emissions. Now that's something I want to hear. Dennis Leary telling us about how the new F-150 is built Ford tough with bamboo. He might not say it that fancy. This is more of a man's man. I'm David Manti. This is Engineering by Design.